Hello, welcome back. So let's continue. Uh, I'm going to, in this video, we will do two more examples or two more questions from the past papers that involve EMF and internal resistance. And then in another video, in a separate video, I will um, look at other scientific method questions from electrostatics and probably Ohm's law. Okay. But that's for a future video. So let's go ahead and look at these two questions. The first one is another question 8 from the Metro Central Education District 2024. That's September 2024. Grade 12 learners conduct an experiment to determine the internal resistance of the battery. They connected the battery to a rheostat, ammeter, and a voltmeter. And then these are they graphed their results. So on the only difference compared to the previous questions on that I've done is that here on the y-axis we have current, and then on the x-axis we have voltage, but that's about it. Nothing else is different. Of course, our linearization is going to look a bit different because we want our y now to be current instead of v. So the potential difference is going to be our x, and the current is going to be our y value, and the intercept is this intercept here that is going to be the EMF, right? So we'll look at here's the intercept when the potential when the current is 0, our EMF is 12 volts. Anyway, let's answer these questions. Let me start with I've already answered 8.1.1. All right, and that's it. That's the beauty about this. If you do the theory, and then these questions become trivial. Okay, and you can see that for 8.1.2, for example, the answer is obviously 4 volts, because if you have the EMF, which is the maximum energy supplied per coulomb, so you from 12 to 8, you've lost 4 volts. So, and then here, this is where we're gonna rearrange our equations so that it looks like like the equation of a straight line, which is y is equal to mx plus c. All right, so but let me go on and write down the answers to these questions as you should answer them. Okay, let me this is not what I want. Where is this question? Here we are. Okay, so let's go on and do this. 8.1.1, we've answered it already. Gives us 8.1.1. This is our EMF. It's going to be the potential difference of an open circuit. So a circuit is open. On this line, on this x-axis line here, the current is 0 everywhere here. So what is the voltage when the current is 0? It's 12 volts. So our EMF is equal to 12 volts. And 8.1.2, the lost voltage when the current is 2. When the current is 2, we have external voltage. So this potential difference we're talking about is the external voltage. That's the V. This is this V here, voltage of the circuit. So if this reads 8, but the EMF is 12, so then we've lost how many volts? 4 volts. So V lost is equal to 4 volts. And then in 8.1.3, we must determine the internal resistance of the battery without using the equation in your calculations. So let me repeat this again. Let me read it again. It says without using the equation in your calculations. Of course, you're going to have to rearrange this equation to be in the form of y is equal to mx plus c, as we've done when we're doing linearization in the videos that I've posted. So this is where I'm going to start. I'm going to start with this equation, but I'm not going to use it in my calculations. All I want to see what it would look like in the form of y is equal to mx plus c, because I have current here in the y-axis, and so that's going to be my y, and the potential difference is going to be my x. Anyway, let me start here. I don't memorize equations, so pardon me. If you already know what it looks like, then you don't have to go through this pain. It's not really pain, actually. It's okay. V external plus IR. And then this is my y. I want this to be my y. So then I will have IR here. And then I will have my minus V external plus E. And then that implies my I is equal to minus 1 over R V external. I have lines, but I'm writing in an interesting way. But anyway, you will have to excuse that as well. Plus E over R. Okay, so this is my y. So now it's in the form y is equal to mx plus c. My y is I. My m, which is exactly what I want, is minus 1 over r. My c is e over r. So I'll just write that m is equal to minus 1 over r. Okay, so then since now I know it is in this form, I can go ahead and calculate the gradient, and it should be trivial. I won't look at any other points other than the ones on the axis. So how I proceed is I'll use 6 and 12. So my gradient, changing the variable in the y-axis, which is I, divided by change the variable in the x-axis, which is v. So that equals when my current is 6 minus 0. My current is 6 when the voltage is 0, minus it's 0 when the voltage is 12. So I get 6 over minus 12, and then that gives me let me pause here a bit here. Okay, so then what do I have? That's my gradient, which I'll write minus r now. Minus r, select this pen. No, that's minus 1 over r, sorry. Minus 1 over r is equal to minus 1 over 2. So therefore, my resistance, my internal resistance is 2 ohms. Okay. Right, and that's the 3 marks there. I would think that's 1, 2, 3. Okay, let's look at this one. In this question, you have grade 12 learners are conducting an experiment to determine the internal resistance of a battery. So you have two groups of learners. Group 1 used the battery 1 with an internal resistance R1, and group 2 used battery 2 with an internal resistance R2, and these are the results. Okay, and again we have this, we're back to the familiar one graph. So the voltmeter reading on the y-axis and the ammeter reading on the x-axis. And then in question 8.1, we explain why the voltmeter across the reading across the battery decreases as the current increases. As you can see, the voltage is decreasing for both groups as the current is increasing. So we must explain that using physics equations, which is we're going to use the formula of the EMF. But before we do that, I'll just going to give you a picture of what the explanation is going to look like, should look like. I'm going to use numbers. I'm just going to select any combination of a random combination of numbers. I'm going to use I'm going to use let's say 12, and then I'm going to use 12 is 8 plus 4. 8 plus 4. Okay, so what's happening here? What's happening here is that if I am not allowed to change this number here, 12, if it must remain constant, and I am allowed to change both of these numbers here, how are they going to so what happens if I have now, let's say I increase this 4 to 6. Let's say I increase this 4 to 6. If I am to maintain this should be constant, if this should not change, then if I increase this number here, then I must decrease this number. So if I increase this number to 6, 8 is going to decrease to 6. All right. Furthermore, if I again increase this number, let's say I increase it to 9. So if this increases to 9, then for this to remain constant, then if I increase this, then I must decrease this so that the combination is 12. So this will decrease to 3. And this is the logic we're going to use for 8.1. So for 8.1, we will have EMF is equal to I into R plus small r. And I'm going to write it as V external plus I R. Okay. So then the explanation goes as follows, that the EMF is constant. Okay. So that's the first one there. First point, that the EMF is constant. So if I increase R, okay, and increase in R, sorry, in current. So if I increase in the current here, implies that IR, okay, increases. Okay, so if IR increases, okay, then V external must decrease. Okay, must decrease so that E remains constant. Okay, so that is my response there for 8.1. You just use this one. If current is increasing, then the loss volts are increasing. So then you must decrease this one, but because you are using the equation, so basically it's a mathematical form that if you increase this, I increasing means this increases, then this must decrease in order to keep E constant. Okay, right. 8.2, which group 1 or 2 used a battery with a greater internal resistance? Again, here you have to recall the linearization to answer this question. It's 1 mark, so this is a knowledge question. So V external is minus R I plus EMF. Okay, so basically how you answer this question, since it's in this form, then all you have to know is that the gradient, the magnitude of the gradient of these lines, both of these lines, I have this form. So we'll look at the gradient of the lines and then deduce that which one should have a bigger R. Basically, if it's more steep, then the internal resistance is larger. And obviously that's group 2, because both of them, they start at 12. But then if you move, the current is 1 amp, then you can see that this drops to 8. Group 2 drops to the voltage of 8. But then the group 1, in order to drop to the voltage of 8, then the current has to be 2 amperes. So this is gentle and this is more steep. So then it's group 2. The gradient of the magnitude of the gradient of this line of group 2 is greater than the magnitude of the gradient of group 1. So the greater internal resistance, since this is R, then if the gradient is larger, then that means R is larger. So then this is 8.2, then it's group 2. Okay, group 2. Why? Because this line is more steep, it has a greater magnitude of gradient. The gradient here, you can calculate the gradient here. From 12 to 4, for example, you drop by 8 over what? Over 2, that's 4. But here, from 12 to 4, you also drop by 8, but then that's 8 over 4, that's 2. So this one is 4, this one is 2. Okay. All right. So let us answer 8.3. Okay. 8.3, we want the internal resistance used by the learners in group 1. I'm just going to write it as minus R, and then I'm going to calculate the gradient in group 1, which I've already done. I'm not going to use the equation. I'm just going to say it's equal to 12 minus 4 divided by 0 minus 4. Okay, so when the voltage is 12, the current is 0, and then when the voltage is 4, the current is also 4. Okay, so minus R is equal to 12 minus 4, that's 8 over minus 4, which is minus 2. Therefore R is equal to 2 ohms. All right. Okay, thank you so much for listening. I hope that you really enjoyed these lessons on on the graphs of EMF and internal resistance. And then in the next videos, I will do the scientific method in other topics, electrostatics and Ohm's law and other stuff. Okay. All right. Thank you for listening. Goodbye for now. Cheers.